Now we move on to the next part of the chapter, acid, bases and salts, and that is indicators. Now, what do you mean by indicator? A particular kind of a chemical which when used with an acid or a base or any other compound, and if it is going to change its color every time in the same manner, then we can say that that particular chemical can be used as an indicator. So indicator tells us whether that particular substance is acidic or basic or neutral. So if it is able to tell me that whether it is acidic, basic or neutral, I will call that particular substance to be as indicator. There are two kinds of indicators. One is a common indicator, which is like litmus paper, then the phenolphthalein, methyl orange, and one could be a pH indicator or universal indicator. So universal indicators will be the one which will be like the one which is going to tell you not only, see, in case of the common indicators, it can tell you only whether acidic or basic, okay, whereas a universal indicator can tell you how much acidic, how much basic or neutral. So it is more better as a universal indicator. So let's see one by one what exactly is this thing, and also what is the measure of acidity and basicity. So first is, indicator are weak organic compounds, acids or bases, which change color in accordance with the pH of the solution. So if the organic compound is such that it changes its color according to the pH of the solution, then it is called as the indicator. So what is pH, right? That's of course the first question which will come in your mind is pH care, okay, right. So indicator dissociates slightly in solution producing ions and unassociated molecules. The color of the ion produced is dependent on hydrogen ion concentration, which is the pH of the medium. So what is pH? It is the power of hydrogen, or we can say that the hydrogen ion concentration. What is the hydrogen ion concentration in a particular kind of a substance? It is the pH value of the substance. So pH value of a medium, pure water is neutral. Okay, pure water is neutral and ionizes very slightly to yield equal amount number of H plus ions and OH ions. So you can see water when it's split, it's going to form H plus and OH. H acidic, OH non-acidic when it's basic. So that's why water is neutral. So water is neutral. The concentration of H plus ion and OH ions are both equal, and that is equal to 10 raised to minus 7 mole per decimeter cube. That is the value over here at 25 degrees Celsius, and hence we just call it as 7. So 7 is nothing but, so when I say the pH value, or we can say the amount of concentration of this thing, it is given as 10 raised to minus 7. This is 10 raised to minus 6 to 10 raised to minus 1. Sorry. Yeah. And this will be 10 raised to 8, minus 8, and then it goes up to 10 raised to minus 14. So this over here, this is indicated as 7. So pH value 7 is nothing but 10 raised to minus 7. So this is pH value 1, this is pH value 14. This is neutral. This side is acid, this side is base. As you go further here, the acid content increases. You can say the acidity, the strength of the acid increases. It's a strong acid. If you go here towards 14 is a strong base. So here, if a particular kind of a solution has pH 1, means it is highly acidic. But 6.9 will be almost neutral, so very less acidic. 5 less acidic. 8 or 9 less basic. 14 highly acidic. Okay, highly basic. Sorry, 14 will be highly basic. 8 or 9 less basic, okay, much more towards neutral. So you see that the product of the two ionic compound concentration is given an ionic product of water, that is 10 raised to minus 7 into 10 raised to minus 7 over here will give you 10 raised to minus 14. That is nothing but the bases. Not to go into that detail, not required for your exam point of view, because it is not asked also anyway. It is just for your information. In fact, this first part is just for your information. Indicators are not a part of your syllabus. It's just for your information. So the pH value represents the strength of acids and alkali expressed in terms of hydrogen ion concentration. So what is the pH value? It is the amount of, or you can say it is the strength of acids or bases on base of the concentration of hydrogen ions present in them. So pH is defined as a negative logarithm to the base 10 of the hydrogen ion present expressed in moles per liter. Not required. Okay, simple. No definition of pH required. Important for you is this, that 7 is neutral, towards 1 acid goes on increasing, the strength goes on increasing. 7 say towards 14, the base, the strength of the base keeps on increasing. So that is what is important over here. Now we have the differentiation between a common acid base indicator and a universal indicator. So we see that a common acid base indicator like litmus paper or methyl orange, phenolphthalein are examples of common acid base indicators. The utility of this is, if you take a litmus paper, it can just tell you blue to red. If it turns blue to red, हाँ acid है. कितना acidic है मालूम नहीं है. Okay, blue to red turns blue, basic है. कितना basic है मालूम नहीं है. So that's why indicates whether a solution is acidic or alkaline cannot be utilized for determination the strength of the acid or the base. Acid or alkali, whether it is strong or weak, you cannot identify by the litmus paper or a phenolphthalein or a methyl orange. Cannot differentiate between acidic or basic solution of different pH values since they change their color abruptly at a certain pH value. So the moment it is going to go to further than a particular pH value, it changes its color. It does not understand strong or weak at all. Like for example, they have given you the list over in the textbook. They have given you this particular table. This table tells you that how the litmus paper is going to indicate. It is going to indicate between pH value 0 and 1 and between 7 and 14. So that is why the moment any particular thing has got a pH value anything less than 5, it is going to turn into red. Anything which is greater than 7, it is going to turn into blue. So that is how it is going to just going to tell you that it is acidic or basic. Similarly, methyl orange is going to change only between 1 and 2.5, 0 and 2.5. Whereas methyl orange pink is going to change only that way, whereas yellow is going to change from 4 to 14. So everything. Phenolphthalein is going to change from 0 to 6 and from 8 to 14. So this is how it is going to be. Whereas in case of a universal indicator, the indicator is going to have a color variation. So that color variations are very similar to our rainbow, that is Vibgyor. So here also it will be red, or if you take from the Vibgyor point of view, though it will be violet, indigo, blue, green, yellow, orange, red. The same thing. Where violet towards violet is the base and towards red is the acid. So this is how the universal indicator is more helpful than a normal indicator. So we see in case of a universal indicator, examples are mixtures of organic dyes or mixed indicators like pH paper or solution. Utility is indicate the strength or pH range of the acidic or alkaline solution. Can be utilized for determining the strength of the acids or alkaline solutions, and can differentiate between acid and basic solutions of different pH values by giving different colors with different pH values. So color change from blue to indigo or to violet to blue can be easily differentiated over here. So when it is going from violet to towards blue, we know that it is going to decrease in the basicity. Whereas it is changing from red towards yellow, it is the acidity is decreasing. A litmus indicator, it is a natural coloring matter obtained from certain lichens. A litmus solution is prepared by dissolving 0.5 grams of litmus in 1 liter of distilled water and filtering. Now, what are the normal color changes which are very, very important, at least for the common indicators? So first thing, litmus paper, when it is neutral, it is going to be purple. Okay, litmus paper when neutral, it is going to be purple. When it is dipped in acid, it turns red, so purple to red. And when it is dipped in alkaline, it is going to be blue. So it is going to be red turning blue or purple turning blue. So that is, color change will be, neutral will be purple, acidic will be red, alkaline will be blue. Methyl orange, neutral will be orange, acidic will be pink, and alkaline will be yellow. Phenolphthalein, neutral will be colorless, acidic will be colorless, but alkaline will be pink. Phenolphthalein alkaline solution will be pink in neutral, colorless in acid, and pink in alkaline. So this was the color changes which is normally taking place or very important for the common bases. Whereas otherwise it is in the pH, that is universal indicator, it is just the Vibgyor, violet, indigo, blue, green, yellow, orange, red, where green is neutral, red is acid, blue, violet is base. Utility of pH value. In agriculture, the pH of the soil is tested for better growth of the crops. For example, citrus fruits need slightly alkaline soil, rice an acidic medium, sugarcane and neutral medium. Dairies check the pH of the milk. So milk pH is 6.6 indicates the milk has turned sour. So if they see the milk, if it is going to go bad, they will check the pH value. If the pH value becomes 6.6, normally it is neutral. If it is 6.6, it is gone bad. Daily technology. So biochemicals. In technology, biochemicals and organic reactions are carried out under controlled pH, and medicine pH value of urine and blood are taken for diagnosis of various diseases. pH values of some common substances. HCl will be 1. Sulfuric acid, dilute sulfuric acid 1.2. Vinegar 2.9, tartaric at 3.5, lactic acid 6.6. And alkaline solution, human blood is alkaline at 7.3, albumin 7.9, seawater 8.5, ammonium hydroxide 11.1, sodium hydroxide 13.0. So that was about the different pH values, acids and bases. This is the end of acids and bases part of the chapter. Now we move on to the next part of the chapter, that is salts. So salts part, again very important, because there are too many different kinds of reactions taking place over here, too many changes taking place over here, too many different ways in which salts are produced. So that's why we have a very, very important part in this chapter, that is about salts. In this initial case, we'll just, I think today I'll just explain you in this video, I'll just explain you the different kinds of salts. We'll not go into the details of the salt. So we see that ions present in the salt in the solution. So salt definition, as this definition, what is salt? A salt is a compound formed by partial or complete replacement of the replaceable hydrogen ions of an acid by a metallic ion of or ammonium ion of a base. So that means, simple thing, salts are those compounds formed by neutralization of an acid and base. Okay, so one of the product of a neutralization of acid and base is salt. We know acid plus base is salt plus water. So here that's the same thing written in words as salt is a compound formed by partial or complete replacement of the replaceable hydrogen ion of the acid by the metallic ion of the ammonium or a metallic ion. So that's why we have this as salt. A salt is an ionic compound which dissociates to yield a positive ion other than hydrogen ion, that is H plus, and a negative ion other than hydroxyl ion. So whatever was the in acid and salts, acid and bases, H plus indicated the acid. So H plus के बगैर जो भी था, that is, if I talk about this way, it is H plus Cl minus plus Na plus OH minus. So whatever is the negative radical over here and the positive radical over here, other than H plus and OH ions, the combination of that gives me a salt. Okay, that is the definition of salt. Now the type of salt, there are normally two kinds of salts. Firstly is, one is acidic salt, another one is a normal salt. So whenever a salt is prepared from an acid, and if the acid has not completely got, the H plus ion has not got completely displaced, what is going to be formed will be a acidic salt. Like we had that equation just about in the next part, earlier part was this was NaOH plus H2SO4 giving me over here as NaHSO4. So this was the one which is giving me NaHSO4 plus H2O. So this H, presence of this H over here makes it a acidic salt. Okay, so when there is a partial displacement, okay, so it is the salt formed by partial replacement of the replaceable hydrogen ion of an acid molecule by the basic radical, is the metallic or ammonium, is going to be called as the acidic salt. So here you can see the complete H2SO4 has not got dissociated, only part of it has got dissociated. So HSO4 comes with Na to give it NaHSO4, which is nothing but sodium bisulfate. So all bisulfate, bicarbonate, all these are the examples of a acidic salt. So when hydrogen is a part and parcel of the salt, it forms a acidic salt. So NaOH plus H2SO3 gives you NaHSO3 plus H2O. So preparation wise, acid salts formed when the amount of base taken is insufficient to completely neutralize the acid. So if the base taken over here is less, it is not able to neutralize this H2SO4 completely, then such a condition could take place. So this is the way the formation or preparation of an acidic salt takes place. Acid salts contain replaceable hydrogen atoms in its molecule. So in the molecule of the acid, in the salt, hydrogen, the replaceable hydrogen atom is present in the molecule of a acidic salt. And hence exhibits all properties of an acid in a solution. So when this dissolves in a solution, it will be slightly acidic in nature. It will give you certain kind of properties of an acid. So that's why it is going to be called as acidic solution. Now we very well know acidic kind of salt can be formed only when you use a acid which is dibasic or tribasic. See, if this would have been only HCl, what would have happened? It cannot form NHCl. It is not possible. So this case is going to be NaCl plus H2O. There is no way that H can be here. So that's why acidic salts are formed only by dibasic or tribasic. Okay? H2SO4, yes, it can form. H2CO3, yes, it can form. H3PO4, it can form. So you can see the one which are dibasic or tribasic are the only acids which can form an acidic salt. So acidic salt is not formed by acids by HNO3, HCl, CH3COH because they are only one replaceable hydrogen ion with them. Now we come to the normal salt. When the dissociation takes place completely, then it is a normal salt. So when this would have displaced completely, it could have formed over here, it could have formed NaSO4, Na2SO4 plus H2O because this got completely displaced, and in such a case what is going to be formed will be Na2SO4 plus, so it will be like this. So that's why Such a kind of a condition over here is complete displacement. So the salts form by complete replacement of the replaceable hydrogen ions of an acid molecule by the basic radical is called as a normal salt. So this will be a normal, Na2SO4 will be a normal salt. So there is no hydrogen atom inside that. So both H ions in the sulfuric acid are replaced by the metallic salt. So here both the hydrogen atoms are replaced by Na, and hence it is going to give me a normal salt. Preparation wise, here preparation kab hoga? When you are having sufficient amount of NaOH over here. If you have got sufficient amount of NaOH over here, then automatically it will be sufficing the number of hydrogen which are present in the acids. Hence they can be formed by sufficient amount of normal salts formed when the amount of base taken is sufficient or is in excess for complete neutralization of an acid or a base. Okay, so that is when the normal salt. Normal salt does not contain any replaceable hydrogen atoms in its molecules and does not exhibit any properties of acid in the solution. And it can be formed by any kind of acid because all the acids, they will be completely dissociated. So whether it is a monoacidic or monobasic or dibasic or tribasic, they all are going to form into their respective salts according to what is the thing which is used. Like if I am using NaOH, it will form NaNO3 with nitrates, NaCl with nitric acid, NaNO3 with nitric acid, NaCl with hydrochloric acid, and Na2SO4 with sulfuric acid, and so on, right? So that is about normal salts. Now so basics, there are also another kind of salts that are, so one we talk about is the acidic salt. So acidic salt had H in it. Now we talk about the basic salt. So basic salt are formed by partial replacement of the hydroxyl radical of a diacidic or a tribasic base. Okay, so if diacidic or diacidic or triacidic base. So if the base used over here is triacidic or biacidic, then it is going to give me a salt which will have an OH in it. Okay, so first case was the amount of hydrogen in the acid was more and OH was less. Now OH is more and hydrogen is less. So we have over here the condition in which the replaceable OH ions over here are going to be replacing by hydrogen ion for the OH are less, and hence the formation of the salts like CuOH and O3. This kind of a thing could take place. There could also be something like CuOHCl. So these are the examples wherein this is a basic copper nitrate, this is a basic copper chloride. This is contains a hydroxide of one hydroxide present in the salt. If one of the hydroxide is present in the salt, then what we are going to get over here will be a basic salt. So formed by partial replacement of the hydroxide radical of a diacidic or triacidic base with the acid radical. You don't need an example, they are not given the example, so not required. And then there are some salts which are just for reference. You just need to know that such things exist, but not for learning. That is double salt. Double salt are the one which are formed by mixing of saturated solutions of two simple salts together and then crystallizing them together for a saturated solution. So the example is alum, which is like alum is K2SO4 dot AlSO4, Al2SO4, and then it is going to be thrice plus water of crystallization as 24H2O. This is nothing but alum. Very, very important certain times. Alum contains a double salt, K2SO4, that is potassium sulfate, aluminum sulfate mixed with the water of crystallization 24. So K2SO4, Al2SO4 thrice, 24H2O gives you alum, which is made up of two simple salts of K2SO4 and Al2SO4 thrice. Similarly, ferrous ammonium, that is a more salt, and which is made up of ammonium sulfate and ferrous sulfate. Then there are some mixed salts, which is like sodium potassium carbonate, which is something like this. It is NaK KCO3. So sodium potassium carbonate, which is having two metal parts. So if some salt is such that it has got two metallic compounds, it is called as a mixed salt. So this was our double salt, and this is a mixed salt. Okay, example of mixed salt or double salt. So double salt, like bleaching powder, is CaOClCl. So that is a bleaching powder. Then there are complex salts, and complex salts are the one which is made up of simple ions and a complex ion combining together to form one complex ion. Like for example, they are given over here as K2 HgI4. HgI4. This is a kind of a complex salt. These are just for reference. This is nothing for learning. So like sodium silver cyanide, sodium zincate, tetraamine copper sulfate, all these are examples of the complex salts. So these were the different kinds of salts which were present, or the different kinds of salts. So we have the different kinds of salts as acidic salt, normal salt, which doesn't have any hydrogen or OH ion in it. Acidic salt has H ions in it. Basic salt, which will have OH ions in it. Then there are double salt, having two salts combined together in the crystalline form. Mixed salts having two metallic parts in the same one. Complex salts is a combination of different substances. So this way it is the different kinds of salts. We'll start with the basic things about the salts in the next video. We'll start with the solubility of metallic salts. Okay.